Right, having done the 2016 exam, let's do the 2017 Level 2 Calculus, Introduction to Calculus exam using the formula that they give you there. We really only need to use these ones here. Okay. Question 1. Function f is given by this thing here, x to the power of 5 plus 3x squared minus 7x plus 2. Find the gradient of the graph where x equals 1. Okay, so we need to find f dash of x first. So the 5x, the 5 comes out the front, and the x loses 1 upstairs. 2 times 3 is 6. And the x loses a power, comes to the power of 1, and then the 7x just becomes negative 7, and the 2 disappears. So now we want to find that at 1, so it's going to be 5, 1 to the power of 4 plus 6 times 1 to the power of 1. Minus 7, so 1 to the power of 4 is 1, so 5 times 1 is 5, plus 6 times 1 is 6, minus 7, so what's that, 11 minus 7 is going to be 4. So m equals 4 when x equals 1. It doesn't ask you for anything else, so that will suffice for now. Right, find the equation of the tangent to the graph of the function f of x is 6 plus 14x minus 2x cubed at the point 218. So we're going to presume that 218 is on that point. First thing we need to do is we need to find the gradient where x equals 2, and to do that we need to differentiate. So this is the original equation. It's written in Taylor format, the constant first, then increasing powers. So f dash of x, that's going to become 14. 3 times negative 2 is negative 6. The x will lose 1, and then we want to put 2 wherever we have an x. So f 14 minus 6 times 2 squared, so 14 minus 6 times 4 is going to be minus 10. So that's going to be the slope at that point 218, and it goes through that point 218. So from there, y minus 18 is going to be equal to negative 10 x minus 2. So y equals negative 10 x plus 20 plus 18, we bring that negative 18 across. So y equals negative 10 x plus 38. And that's our final answer for that. So far, so good. All right, this one. The movement of an object is recorded from the time it passes a fixed point, okay? After t seconds, it will be at a speed v meters per second, which can be modeled by the function v of t equals 0.5 t squared minus 2t plus 1. Use calculus to find how long it takes to reach an acceleration of 2.8 meters per second. Okay, well, acceleration with respect to time is when we differentiate with respect to time velocity. So we're going to take that and differentiate it and set it equal to 2.8 and solve for t. So v t is 0.5 t squared minus 2t plus 1. V dash of t, 2 times a half is 1. So it's going to be t to the power of 1 minus 2. That's going to be our acceleration. And we want to set that equal to 2.8 and solve for t. So we're going to add 2 to both sides. So it's when t equals 4.8 seconds. Is that it? Are we done there? Okay, yep, that's all they were asking for. Okay. Let's move this up a bit. A tangent to the graph f of x equals 3x squared minus 4x has the gradient of 2 and passes through the point 5, comma a, where a is a constant. Find the value of a. Okay. So if this is the original function and we want to find the gradient, we're going to have to differentiate. So here's the original function, just copied from above. And that means the f dash of x, 2 times 3 is 6. The x loses 1, minus 4. And we want to set that equal to 2. So we want to find where this graph has a gradient of 2 and solve for x. So let's add 4 to both sides. So 6x equals 6. Divide both sides by 6. Pretty trivial event. It's when x equals 1. So that means that it has a gradient of 1. Gradient, this thing here has a gradient of 2 when x equals 1. Okay. And we need to find a point where x equals 1 on this graph here. So 3 times 1 squared minus 4 times 1. And it's going to be 1 squared is going to be 1 times 3 is 3 minus 4 is minus 1. So it passes through the point 1, minus 1, and the gradient of 2. And that's more than enough to find the product, the equation. So y plus 1 must be equal to 2x minus 1. So y equals 2x minus 2 minus 1, 2x minus 3. So that's the tangent that has the tangent to this original line here. But we want to know where this is when x equals what y would be when x in this one equals 5. So 2 times 5 minus 3 is 7. So therefore a equals 7. Bit convoluted, we'll go through it again. Here's the original equation. We differentiated it and set that equal to 2 to find out where it equals, the gradient equals 2, and we found out that it was when x equals -1. Then we use that gradient 2 to find the other point on that straight line, that tangent line, and we got that. Then we put from this one here x equals 5 to find a, which was 7. So it's sort of a step 1, step 2, step 3, step 4 before we got the final answer. Sorry, I just had a drink. So if f of x is x cubed plus ax squared plus bx plus 2 has turning points when x equals -1 and when x equals 3. Find the values of a and b. Okay, well, if f of x, I'm just going to copy this out just so I can work on it. Plus bx plus 2. Now we want to differentiate it so we can find the slopes. So 3x squared plus 2ax plus b. And we know that this equals 0 when x equals -1 and when x equals 3. So let's put them in and see what we get. So let's put in x equals -1 here first. So 3 -1 squared minus 2a plus b equals 0. So 2 times a times -1 is -2a, and the b is just by itself. So -1 squared is 1. So 3 times -1 is 3 times 1 is 3 minus 2a plus b equals 0. In fact, I'm going to rewrite that. -2a plus b equals -3. I'm going to bring that -3 over. You'll see why in a second. And then I'm going to do the same for this with 3 instead of -1. So 3 times 3 squared plus 2a times 3 plus b, and that equals 0 as well. 3 squared is 9. 3 times 9 is 27 plus 6a. 3 times 2 times a is 6a plus b equals 0. And I'm going to rewrite this one again. I'm going to bring that 27 over. Equals -27. And now we have two equations and two unknowns. So I'll write them one on top of the other. Two equations and two unknowns. And I'm just flat out too lazy to solve it myself. So I'm going to use the calculator. So -2, 1, -3, 6, 1, -27. Solve. A equals -3, B equals -9. And we're done. Okay. So these ones always come up. There's at least one in your exam. So this is the original function, and then we want to graph f of x on a different, for the same graph on a different set of axes. Well, this is a parabola, so what we get is going to be a straight line when we differentiate it, and it has a turning point here. So that means that directly below it, this one must cross the axis at that point, and it's going to just be a straight line. So it kind of makes sense, because for all of this part to the left of that part there, it's above the x angle, Therefore, the gradient is positive. And then here, the gradient is 0, so it crosses the x-axis. And then for everywhere past that, it has a negative slope, so the gradient must be below 0, must be a negative number. Easy marks, really. Okay, another pretty similar question to some previous ones we've had in this test already. So they give you the original graph and it has this b in it, and they tell you it has a turning point when x equals -1, find b. Okay, so if we know it's got a turning point, we're going to need to differentiate it. So here's the original function, 2x cubed plus b x squared minus 2. So when we differentiate it, 3 times 2 is 6x, and we lose a number, plus 2b x, and the 2 disappears. And we know that when we put in a -1 in there, it equals 0. So 6 times -1 squared plus 2b times -1 equals 0. So -1 squared is 1. So 6 times 1 is 6, plus 2b times -1 is going to be actually -2b. And that equals 6, equals 0. Let's take 6 across. So -2b equals -6. Divide both sides by -2. So therefore b must be equal to 3. And there's our final answer. And maybe you can hear my tummy rumbling. It means it's time for lunch. But b equals 3. All right, cracking right ahead. Use calculus to solve the graph function and prove that the local maxima is there. Well, I don't like this that form there, so I'm going to expand it. So y equals 3x cubed minus x to the power of 4. And I want to differentiate it, so dy dx is going to be 9x squared minus 4x cubed, and I'm going to differentiate it again because I want to find out whether that's a maximum or minima. So 18x minus 12x squared. So there is our first derivative, and we want to have a turning point, so it equals 0. Now this we can factor out the x squared in there, and we can be left with 9 minus 4x, aren't we? Yeah, going to be left with that. We can divide both sides by x squared, and so 9 minus 4x equals 0. So I'm going to take 9 away from both sides, so minus 4x equals minus 9. X equals 9 over 4. So 9 over 4 is indeed a turning point. And then when I put 9 into 4 in here, I should get a number less than 0. So 18 times 9 over 4 minus 12, 9 over 4 squared, and I have no idea what that is off the top of my head. Let's do it. 18 times 9/4 minus 12 9/4 squared minus 81/4, which is a minus number, so therefore 9/4 is a maxima because of the second derivative test. Okay. All right, we're up to question 3 already. So we're told that the gradient graph of the function, that's a strange way of putting it. This is the first derivative of this. So we know that this original line f of x goes through that point there. So they've given us an initial point. So if we have f dash of x equaling 6x squared minus 2x plus 4, when we integrate, we get that. So the 6 stays there, the x stays there, the 3 goes instead of the 2 gets 1, we have to divide by 3. The negative 2x stays there, but now it gets a 2, and we have to divide by 2. And the 4 picks up an x, and don't forget the c. We know that 1, 3 is on that graph. So whenever x equals 1, y equals 3. So we can cancel a little bit as well. So 6/3 is 2x cubed minus x squared. Those twos are going to just cancel out, plus 4x plus c. So that tells us that, we're just going to move that up a bit. 2 times 1 cubed minus 1 squared plus 4 times 1 plus c equals 3. So 1 cubed is 1, 2 times 1 is 2, 1 squared is 1, so minus 1, 4 times 1 is 4, plus c equals 3. So c is going to equal to 3 minus 2 plus 1 minus 4. 3 is 1, 2 minus 2. C equals minus 2. So find the equation of the function f of x. Well, f of x is going to be 2x cubed minus x squared plus 4x minus 2. And we're done. Nearly done. So this one says that an object can move in either direction on a straight path, straight track, and has a constant acceleration of minus 4 centimeters per second. A fixed point P is marked on the track. So I guess there's P there. When recording of the object's motion begins, the object is 12 centimeters from P. So we'll say it's there when time equals 0. And it is moving away from P and has velocity of 6. It's not meters per second, it's centimeters per second. So using calculus, find the speed. Okay, so they don't want velocity, they want speed of the object 5 seconds after its motion, after it began its motion. Well, velocity is when we integrate acceleration with respect to time. So if acceleration is constant at minus 4, that means that the velocity must be equal to minus 4 t plus c, but we know what c is, it's 6. So therefore find the speed after 5 seconds. So the velocity after 5 seconds must be minus 4 times 5 plus 6, which is minus 20 plus 6. So that's minus 14 centimeters per second, and velocity, which is in speed, is 14 centimeters per second, because speed doesn't rely on direction. Okay, so far so good. Next one, let's just move this up a bit. What is the maximum distance the object can move? Well, we need to find where the velocity equals 0. So the velocity for any time is going to be minus 4t plus 6. We set that equal to 0 and solve for t. So we take 6 away from both sides. Minus 4t equals minus 6. So t equals 3 over 2. So 1.5 after 1.5 seconds. Okay, so now we want some sort of function for the position. So I'm going to just call that pt. Usually you would use an s, but they use p there, position of t, and that's going to be the integral of velocity with respect to time, and that's going to be the minus 4 stays there, the t squared, but we have to divide by 2, plus 6t plus, now what was the initial condition? What's the c? It's plus 12. That's the position at any time, and we want to set time equal 1.5. So we would grab our trusty old calculator. If it opens, there it is. Memory cleared. So this is going to be minus 2 times 1.5. Whoops. Minus 2, 1.5 squared, plus bracket 6 times 1.5 plus 12 equals 16.5. And what's the unit? The unit is centimeters. So I guess here is P here, and that's 12 centimeters. So it makes it out to 16.5 centimeters before it starts coming back again. And that's that one done. This is very, very typical. A question that you'll get in the exam. So we start with a square piece of cardboard like that, and we have to cut away these sides here. So if it's 30 from there to there and 20 from there to there, and that's 30, each one that we cut off, this distance from here to here must be the same as from here to here, and it must be the same from here to here as here to here. So I'm going to call that one X. Okay, so the volume of this one, this from here to here, must be 20 minus 2x, because there's an x there and an x there. And this distance from here to here must be 30 minus 2x. Okay, and the height is going to be x. So therefore the volume as a function of x is going to be that side there, 30 minus 2x times 20 minus 2x times x. So let's expand out this bracket here. So 30 and then minus 2x, 20 minus 2x. So 30 times 20 is 600. 20 times minus 2x is minus 40x. Minus 2x times 30 is minus 60x. Minus 2x times minus 2x is 4x squared. So collecting those terms up, we get 4x squared minus 100x plus 600 times x, and then now we put in the multiply all of these terms by x. So 4x cubed minus 100x squared plus 600x is going to be the volume depending on our x. Now I'm going to differentiate that because we wanted to optimize it. So I'm going to differentiate that. 3 times 4 is 12x and it loses 1. 2 times negative 100 is negative 200x, and the x here disappears. It just becomes 600. Then I'm going to set that equal to 0 and solve. And I have no idea whatsoever what that would be when I come to solve it. And it's a polynomial of degree 2. So 12x squared minus 200, 600. So it's going to give me two answers, 12.74 and 3.93. $12.743 and 3.924 3dp. Okay. To find out which one is the max and which one is the min, we're going to differentiate this again. So 2 times 12 is 24x minus 200. When we put 12 in here, let's get out of there. So 24 times 12.746 equals some positive number minus 200. It's still a positive number, so that must be the minima, and I suspect that would be all of the boxes taken out. And if we put this into this equation, I suspect we're going to get a number less than 0, which means it's a maxima. So 24 times 3.924 minus 200, it's still going to be a negative number, negative 105. So that's our maxima. So it's maximized when x is 3.924. Now let's work out what our volume would be. So our maximum volume is going to be 30 minus 2, 3.924. In fact, that's a waste of time. Let's just go straight to this one here. Much better. Or 3.924 cubed minus 100, 3.924 squared plus 600 times 3.924. And we put that in our calculator and we're going to get some horrible funky number. So 3.924 to the power of 3 is that times 4 is 241.683 minus 3.924 squared times negative 100 equals negative 1539. 778 plus 600 times 3.924 2354.4. So our maximum volume is that number there plus 241.638 minus 1539.778 is 1056.305 centimeters cubed. Oh, and that's our answer.